Cost, behavior, and relevant range. That is the topic for tonight. Relevant range. What exactly does it mean? The relevant range means the maximum productive capacity of your plant and machinery, your manufacturing plant. How many units can you produce depends upon the size of your plant. Ji Madhu Walaikum Assalam. And how many units can you produce depend upon the contracts with the labor union. Labor union specifies how many hours they are willing to work, and that puts a limit to your productive capacity. So the manufacturing plant will set a productive capacity. How many units can you produce depends upon the contract with your labor union. And how many units you can produce could also depend upon your suppliers, how much material they will provide you, and this would define how many units can you produce. So your productive capacity, your limit, is defined by these three, or maybe more, some other factors that will determine how many units can you produce. Right? Plant size, contract with labor unions, or the agreement with suppliers regarding the provision of raw material. Now, the important point for us to know, within this relevant range, within this limit, we will observe two things. First, your per unit variable cost would remain the same, and your fixed cost in total, they remain the same. Per unit variable cost stays the same and fixed costs stay the same. And of course, it will happen just for the short run, because in the long run, in the medium run, things change. Your fixed cost change, your rent changes, your insurance premium changes, your depreciation figure may change, the salary of your production staff may change. But in the short run, within the relevant range, we will observe two things. Your variable cost per unit would stay the same, and your fixed cost in total would stay the same, right? Now, let us just discuss this with the help of an example. A company requires 1 unit of direct material to be used in each finished good it produces, and this requires $10 of material. So input cost per unit is 10, 10, 10, 10, 10. Whether you produce 100 units or whether you produce 10,000 units, each unit would require $10 of material. This is the variable cost per unit, and it stays the same within the relevant range. But beyond, let's say, if you want to produce 100,000 units, then of course your variable cost per unit may change, because at this high level of productive capacity, you would purchase more units, and maybe your supplier might provide you a bulk discount. So your input cost might reduce to $9 or maybe $8. So within the relevant range, your variable cost per unit would stay the same. And as you keep on producing more and more, your total variable cost or the material cost would go up. Let us draw this on an x-axis and y-axis arrangement. If you take units on the x-axis, and if you take your cost per unit on the y-axis, what you see is that within the relevant range, every unit will cost you 10, 10, 10, 10, 10. Answer Walaikum Assalam. It stays the same, $10 per unit, $10 per unit. And as you keep on producing more, your variable cost for material, it keeps going up, right? So these two are plotted in this graph, and units and the variable cost per unit total is plotted this way. So what we see from here, within the relevant range, your variable cost per unit remains constant in the short run, and your total variable cost, right now in this example, we just have Cos Walaikum Assalam, Ahrar Walaikum Assalam. We only have the material. So your total variable cost for material varies proportionally with volume. If you produce more units, your total variable cost would be more. But on per unit basis, it stays the same. So this is the important point to learn, that your variable cost per unit stays the same. Yes, Rajesh, relevant range is determined by your manufacturing plant. How many units can you produce depends upon the labor contract with your trade union, or maybe the suppliers that he will be providing you material at this rate. Beyond that range, the cost can change. Your variable cost per unit may change. Your fixed cost in total may change. So this could be the size of your plant, or your contracts, could be anything that restricts your productive capacity and your variable cost per unit and your fixed cost in total remain same within that relevant range. So this is totally dependent upon these variables: productive capacity, contract with your trade unions or with the suppliers. Right? So I hope you got the idea. Now let us see what about the fixed cost. Your fixed cost in total remain the same again in the short run. Like your rent stays the same, at least for a year. Your depreciation stays the same. Your insurance premium for the year stays the same, regardless of the level of production. But this will happen only in the short run. But in the longer run, things change, right? Your productive capacity changes, the contract with your trade union change, and things may change in the future. So let us see how rent behaves on per unit basis and in total. Now, historical cost of assembly line is settled. It is 1 million per month, but its cost per unit decreases as production increases. Now, listen to me. If you produce 1 unit, you have to incur $1 million, the cost of assembly line. If you produce 100 units, the cost stays the same. The total cost, fixed cost, stays the same in the short run, 1 million, 1 million, 1 million. Now, if you plot it along the axis, you would see right here that your fixed cost in total stays the same, 1 million, no matter you produce 1 unit or you produce 10,000 units. But beyond this, Rajesh, beyond this level, if you want to produce more than 100,000 units, in that case, this assembly line would be insufficient. You may have to install a larger assembly line to produce more than 100,000 units. In that case, your fixed cost of assembly line will go up, right? So this limit could be productive capacity. It could be the contract with vendors. It could be anything that limits your output or limits your production capacity. Now, the interesting part is that when this fixed cost is divided with the number of units called the fixed cost per unit, it will fall. 1 million upon 1, 1 million upon 100, 1 million upon 1,000. As you keep on producing more and more units, your fixed cost is being distributed on a larger number of units. And that is why your per unit fixed cost keeps on falling. And this is nicely shown on this graph, that as you produce more and more units, you will find that this fixed cost per unit keep on falling, and these two lines will keep on moving together till infinity, and they will never meet. This is called horizontal asymptote. These two lines keep on moving forever, but they will never meet because your fixed cost per unit can never be absolute zero. It will be 0.00000039 or whatever, but it will not be an absolute zero. That's why these two lines keep on moving together. This is called horizontal asymptote, right? So fixed cost is distributed on the number of units. If you produce more units, your fixed cost is distributed on a larger number of units. So that's the conclusion now. Your fixed cost in total remains unchanged in the short run, and your variable cost per unit stays same in the short run, right? So that makes things much understandable. What if you have a cost structure which is semi-variable, sometimes called the mixed cost? In this case, your fixed and variable costs are combined to give you the total cost. Let's take the example. A company rents a piece of machinery to make its production line more efficient. The rental is $150,000, which you have to pay whether you produce no unit or whether you produce 10,000 units or whatever the limit is. And your variable cost is $1 per unit produced. So if you produce none, no variable cost. If you produce 100 times 1, 1,000 times 1. So as you keep on producing more and more units, your variable cost keeps on going up. So what would be the total cost? Total cost is fixed plus variable. Fixed plus variable. Fixed plus variable gives you 155. So mixed cost is the combination of fixed and variable. This looks quite nice, quite easy, because fixed and variable have been nicely given separately, and you can add these up to get your final figure for total cost. What if we plot it on the graph, what you see is the line starting from this point, indicating that this part from here till this point This part is the fixed part. This part is the fixed cost. Because if you produce no unit, still you have to pay 150,000 units, $150,000. And when you start producing 1, 2, 3, 4, this part is the variable part. So combined fixed cost and variable cost will give you the total line representing the total cost. So total cost is made up of fixed part, 150,000 units, and every unit produced at $1. So combining these two gives you the total cost. So now what we got, what the final understanding we have got is that your variable cost per unit stays the same, and it is reported or shown this way on the axis, variable cost per unit. Your fixed cost in total stays the same, total fixed cost. And if you have a mixed cost, the line will be a little different. It will start from this point onward. This will be the total cost representing partly fixed part, and the remaining part is the variable part. Now, the most important part here, which you are most likely to be tested on your exam, is how to split the variable and fixed cost into its components. Like, look at this. We have been given machine hours spent in each month. In April, we worked for 1,000 hours. For May, 1,600 hours, 1,200, 800. And at this level, we have different maintenance costs, 22, 34, and it keeps on going up and down. Now, let us test what kind of cost it is. Clearly, it is not fixed. This maintenance cost is not fixed. Why? Because every number you see in this column is different from each other. Then could it be the variable cost? If it is variable cost, if it is truly variable cost, then it has to be same on per unit basis. That is what we have just learned, that variable cost per unit stays the same. So 2275 upon 1,000 gives you 2.25, 2.275. If this is true, we should have exactly the same number in the next combination. Dividing 3,400 with the 1,600, it is 2.13. Clearly, it is not same on per unit basis. So this is not variable cost either. This is not fixed cost then. Then what is it? It's neither variable cost entirely nor fixed cost. But what we see that when we work 1,000 machine hours, our maintenance cost was 2275. But when the hours of activity increased from 1,000 to 1,600, the overall average cost fell, which is a convincing evidence that it has some fixed part to it. And this fixed part is being allocated to more machine hours. As you keep on producing or working more machine hours, your maintenance cost per machine hour will continue to fall. Right? This is evidence. Now, let's say if we decrease the our hours of activity, you would notice that this cost will jump again. 1,900 divided by 800. See, it has jumped to 2.38. Now, this is the specific idea. How do we know which cost is which? Fixed cost can be just seen that it's a fixed number. Variable cost per unit stays the same. So it is neither variable nor fixed cost. It's basically a mixed cost, because as we increase machine hours, it falls. But as the machine hours are reduced, it increases. So this is a feature of mixed cost. Mixed cost per unit decreases as more input is put, and it decreases and increases opposite to the hours of activity, right? Now, let us try to apply this idea into a question where we would be required to differentiate between different cost structures. This one be the good. This is a good one. Or why don't we do this first? Now, Fowler Company provides the following summary of its total budgeted production cost at 3 production levels. We have been given 4 different costs, cost A, B, C, D. Yes, semi-variable. I will explain this concept a little while later, just in a few minutes. Fraser has identified the fixed. You are right, Fraser, 400 is a fixed cost. We'll discuss this concept. How do we do that? But let us first learn how do we distinguish between different costs, which of these is variable, which is semi-variable, which is fixed. Now look at this. Cost A, B, C, D. We have been given 4 costs. And I am absolutely sure that cost C is fixed, because no matter the level of activity, 1,000, 1,500, 2,000, the amount stays the same, 1,000, 1,000, 1,000, right? So this is clearly fixed cost. Now let us test cost A. Clearly, it is not fixed because the numbers are variable. Let us see if it is purely variable. 1420 upon 1000 gives you 1.42. 2130 divided by 1500, it is 1.42 again. And 2840 divided by 2000, 2840 divided by 2000, 1.42 again. Clearly, cost A is variable. Why? Because it is same on per unit basis. This is the unique feature we just learned, that the variable cost per unit stays the same. So this is variable cost. Now let us see what about cost B. 1550 divided by 1000, it will give you 1.55. 2200 all clear, divided by 1500, it gives you 1.47. It is falling on per unit basis. 2900 divided by 2000, it is 1.45. 1.45. So as you can see, if we are increasing the number of units, the average cost is falling. So it is a mixture of variable and fixed cost. So we will call it the semi-variable cost. And what about the last one, cost D? 1630 upon 1000 number of units produced, it is 1.63. Divide 2445 with the 1500. I'm using a different calculator today, and it is giving me trouble. 1.63. And I'm sure for the last one, it is 1.63 as well. So you just see that these costs are same on per unit basis. These costs are also same on per unit basis. So this is the unique feature of variable cost. So now what we have is the variable cost, semi-variable, fixed, and variable. So that would make D to be the correct option. D to be the correct option, right? So this is how we identify which cost is which, variable, fixed, semi-variable. Now, on your exam, we will be required to split this mixed cost into its variable component into fixed component. So this mixed cost needs to be split into its component parts. We have two methods. One of them is highly examinable, Hylo method, and other one is not in your syllabus. You just need to know what it is. There is no computation, nothing. You just need to be aware. So this Hylo method is testable, highly testable on the essay section also. But the scatter graph method, you just need to know what it is. It is not practical to do it on the exam. It involves statistics. Now, what is Hylo method? Let me explain with the help of this example given here. It is, of course, not a very good method. It's least accurate, but it's a quicker method. And this is the only method you would be tested on your exam. So what you are required to do in Hylo method, you have to adjust or you have to find which of these is the highest activity. This picture itself is revealing highest, lowest, tallest, smallest. So in Hylo method, you need to identify this is the lowest activity. I call it LA, representing the lowest activity, 800 machine hours. And this represents the highest activity. I am going to ignore all the others, just the highest and the lowest. Others I'm not interested in. Yes, Ibrar, it is also there. Hylo method is also in your correlation regression. Correct. Now, at this level, 1600 highest activity, this 3400 represents the highest cost or the cost at highest activity level. And 1900 is the cost at the lowest. We call it HA or call it the lowest cost, highest cost and the lowest cost at highest activity and lowest activity. Now you're going to use a formula, variable cost per machine hour or per unit, whatever your base is equal to highest cost minus lowest cost upon highest activity minus lowest activity. Please note this formula down. It's a very simple formula which you can use to find the variable component, fixed component. The highest cost in this selected part is 3400. The lowest cost is 1900, lowest maintenance cost. Highest activity level was 1600 and the lowest is 800. If you simplify the numerator and denominator, you will get 1.875. You will get dollar 1.875. This is your variable cost per machine hour. Machine hour is the base. You may have labor hour as your base. You may have number of units as your base. So you can have anything depending upon the question's information, right? So this 1.875, it's the variable cost per machine hour because this is the base, activity base in this question. Now, first part is calculated. Variable cost is 1.875 per machine hour. Now we have to find the fixed cost. And please remember, we will only be using the highest and the lowest activity and none other pair, just this highest and the lowest. We are going to ignore all the other data pairs, just the highest and lowest. Now we can just calculate any activity. Take, let's say, if I take this maze activity, I have 1600 hours, machine hours, and each is at 1.75 rate for variable cost. This will give me the total variable cost, 1600 hours into 1.875 multiplied by 1600. This gives me the total variable cost 3000. If the total variable cost is 3000 and the total cost is 3400, this clearly means the remaining 400 is the fixed cost. You say, no, I don't want to use this highest activity level. You want to use the lowest one. Still, you will get the same fixed cost. Absolutely, boss. If you use the other pair, still it will get you the same answer. Now, in this case, you have 800 machine hours multiplied by 1.875. 800 multiplied by 1.875. It gives you 1500. Variable cost is 1500 and the total cost is 1900. So the difference between the total cost and the total variable cost is 400. Again, this 400 is the fixed cost. Now, why I say you need to take only the highest and lowest, because your Hylo method is only considered for the highest level of activity and the lowest level of activity. There is always a risk. If you take any other pair, your result might be inaccurate. The reason being is that your data points are not always uniformly laid down on a straight line. If they are laid down on a straight line, then Gauss, you can take any pair you want. You can take this or this, you can take this or this, or maybe this or this. You will get the same variable cost per unit. You will get the same fixed cost. But since our cost is not entirely a straight line, that is why you should always take the highest activity and the cost at highest activity and the lowest activity and the cost at lowest activity. Just Hylo, reject every other point. So this is the method permitted or allowed in your or tested on your CMA exam. So you need to follow accordingly, right? It is least accurate, but it's a quicker method and examinable one. Now we have both. We have got fixed cost, which is 400. And we have got the variable cost per machine hour, which is 1.875. So now we have the equation, the total cost function. Total cost is equal to 400, which is fixed part, and 1.875 times the machine hours we intend to use. Now in this formula, you can just input the machine hours. Let's say in October, I want to work for 950 machine hours, and I want to estimate what is going to be the maintenance cost. Just plug in 950 in this equation, multiply it with 1.875, add 400 to it, you will get the estimate of total cost, total maintenance cost for October. This is what we use. Now the other method, see, this is the equation. 400 is the fixed portion and 18.75 is your variable per machine hour component of the cost structure. Now, what about the regression or scatter graph method? You just need to know what it is. It's not examinable. It involves stats. In regression or scatter graph, we use a more complex method. It's a complex method clearly because it involves some complex formulas. We take all the pairs. In the previous one, we just took the highest and the lowest. This method is more accurate because it considers every pair of data, every number combination in this arrangement. And every data element is considered. Using this, the regression line you will come up with, it will be very accurate. Now, let's say the equation I came up with, the Hylo method is 400 plus 1.875 multiplied by machine hour. This is established using the Hylo method. Using the scatter graph or regression method, where every point is considered, and we draw a line that has the least distance from each of these points, that line might look something like this: 375.29 plus 1.3945 times machine hour. This equation will be much more accurate because it has considered every pair of data. Unlike in our example, we took only the highest and the lowest, right? So this method, the scatter graph method, the regression method, is very accurate, but it is more complex. So you just need to know that this method exists. And if it is tested on the exam, you will simply be given the equation and you will have to apply it. You don't have to derive the regression equation, you will be given. Otherwise, if the equation is to be established, you will use only the Hylo method to calculate to drop the equation. So let us do a few questions to explain or understand the idea. Now here we have, this is it. The controller of Joy Company has requested a quick estimate of the manufacturing supplies needed for the Morton plant for the month of July, when production is expected to be 470,000 units. This is the planned production to meet the ending inventory requirements and to meet the sales target for that particular month. Okay, now, Joy Company's budget analyst has the following actual data for the last 3 months, March, April, and May. These are the production units in the previous months, and these were the manufacturing supplies used. Clearly, this number is variable, so it is not a fixed cost. Could it be a variable cost? You can do that. You can divide each of this pair, 723,060 upon this. You will find the number that is variable. It will fall when the activity is increased to 540, and it will increase when it is raised from 540 to 480. Let me do it to you. You'll know what this is all about. Let me explain the concept here. I'm going to divide 723,060 upon $450,000. This gives me per unit of 1.61. Manufacturing supply cost per unit is 1.61. When the activity is increased, this number should fall. Let's see, 853,560 divided by 540,000. It fell to 1.58. And since the activity is now decreasing, this number now per unit should increase. 766,560 divided by 480. You don't have to do it every time. I'm just trying to explain. And now again, it's 160 per unit. So this is clearly a classic example of mixed cost, and we have to use the Hylo method to separate the fixed component from the variable component, and we need to establish an equation. And using that equation, you will have to estimate what would be the manufacturing supply cost if we produce 470 units. So first of all, you will have to identify the highest activity. This is the one. And this is the cost at highest activity, highest cost, call it. And the lowest one, this is the lowest activity. And this is the lowest cost. Highest activity and lowest activity. Now, the next step we'll do is to calculate the variable cost per unit. This time it is not machine hour, it is per unit. So you will take the highest cost, which is 853,560, lowest cost, which is 723,060, divided by the units in highest activity 540 minus 450. Madhu, excellent. You saved my lot of time. Thank you. It is 1.45. So $1.45 per unit. This is the variable cost per unit. Now we need to find out the fixed cost. You can use any of the pair, either the first or the second one. Just use any of these, otherwise you might get the wrong answer. Let us take the second one. If 1.45 is your variable cost per unit, multiply this with 540. Multiplying with 540 will give you the total variable cost 540 multiplied by 1.45 gives me 783,000, right? 783,000. If this is the variable cost, total variable cost, then the difference between the variable cost and the total cost should give you the fixed component, less 853,560. And absolutely right. It is 70560. This is your fixed component. So fixed cost is 7560 and variable cost is 1.45. Right now, we have the function now. We have now the cost function. Our total cost can be estimated using this function. Total cost is equal to 1.4, fixed cost is 70560 plus 1.45 multiplied by the number of units to be produced. Since we intend to produce 470,000 units, you simply have to replace Q, the quantity, with 470,000 units, and then simplify the simple linear equation, and you will get your answer. And Khizr has calculated, he says 759310. Let me check it. 1.45 multiplied by 470. To this add 70560. This gives me 752060. This is your total cost estimated at this level of activity. So that makes D to be the correct option. So this is how you use the Hylo method to identify the variable part and fixed part, and using this you can estimate the cost. Let us try to solidify this concept using another example, this one. Jackson Company has the following information for the first quarter of this year. We have got the machine hours and the cleaning expenses. Clearly, it is neither fixed, it has to be the mixed cost, because it says using Hylo method, what is the variable cost of cleaning per machine hour? So what we're going to do, we're going to identify the highest level of activity. The highest level of activity, this is the highest activity. And we need to find the lowest level of activity, and this one appears to be the lowest activity. This will be the high cost, this would be the low cost. Now, we need to find the variable component, variable cost per machine hour this time. It is the highest cost, 1200, lowest cost being 800, divided by 2600 less 1600. So it is 400 upon 1000, and Ibrar, excellent, you're right. It is 0.4 per machine hour. So this is the variable part. So that makes A to be the correct option. In the second part, it says find the fixed cost. I told you, you should use only this pair, the highest part and the lowest part. Otherwise, you might get the wrong answer. This is either this one or this one, right? So what we can do, take either of these. Take this, let's say, the 1600 multiplied by 0.4. This will give you the total variable cost. Quick way of doing it. 0.4 multiplied by 1600. So your total variable cost comes out to be 640. Whereas your total cost at this level is 800. So the difference between the total cost and total variable cost would be the fixed cost. And that is 160. Yes, excellent. 160 your fixed cost. So that makes A to be the correct option. Now we have got the equation. The total cost function is equal to the fixed cost 160 plus 0.4 times number of machine hours. You just input the number of, let's say in May, we intend to work 2700 machine hours. You can just input this 2700 here and you can get an estimate of the total cleaning expenses. This is how we use the Hylo method to identify or establish an equation and then go for the estimation. Now, next part. Regression or scatter graph method is just included for your knowledge. You just need to know that it's an accurate method. Much accurate. Let me do another question that should explain the idea to you. The least exact method for separating fixed cost and variable cost is the one that we have done. Hylo method is the least accurate. Computer simulation, very accurate. Least square method that we just discussed, it is very accurate. Matrix algebra is a very accurate method. Hylo is the least method. Now, I would like to explain this least square method, what basically this means. Using the scatter graph method, the least square method, we take every point along the line and we are able to establish a line that has the lowest distance, the least distance from each of these points. Some of these points will have a positive distance. Some will have, of course, the points lower the line, they will have the negative distance. So in order to remove this negative anomaly, we take the squares of the number. The least square means the least distances from these points. So resultantly, the equation that you will come up with will be a very accurate one. And this equation will help you do a better forecasting, will help you make better forecast for the future, right? Okay, now, so what we have learned so far is that the relationships are predictable, they are linear. We learned at the very outset that your variable cost per unit stays the same. your fixed cost in total, which you call the total fixed cost, it stays the same in the relevant range. And your total cost, including variable cost and fixed, it takes this form. So this is variable cost per unit. This is the total fixed cost. This is the total cost, including variable and fixed part, right? So these are all linear functions. You can see the combination, the behavior of the cost is a straight line, predictable. We can use this for budgeting purposes, but not every cost function is linear. Look at this. This is, we just learned a little while ago, fixed cost per unit falls. As we keep on producing more and more units, your fixed cost is split on a larger number of units. Your split cost is like this line will keep on moving together. This is called horizontal asymptote. Your fixed cost per unit will keep on decreasing and decreasing continuously, but it will never be zero. So fixed cost per unit falls, and this line here, clearly it's not a linear function. This is called non-linear cost function. So your function can be linear, can be non-linear. We are more comfortable with linear cost functions because they are much easily identifiable, and we can use them for projections. We can project this cost. We know if this is the activity level of 10,000 units, so at this level, this is the total cost, variable cost. If we increase our level of production at this, so we can estimate this cost. But using the curvilinear or non-linear function, this would be little difficult. Now, coming back to the answer to your question, we have another type of cost called the step cost function. This is an interesting, and this should explain you the idea of semi-variable or semi-fixed. Now, listen. What we have learned so far, answer, this cost, which is partly fixed and partly variable, this is called semi-variable. Right? That's what we have done so far. But the cost that takes steps this way, it remains fixed for a certain level. Maybe your rent stays the same for a certain level of occupancy. You can store maybe 10,000 units in this space. When the units increase from 10,000 to 20, you have to take another warehouse on rent. So your cost takes step this way. This kind of cost is called step cost, but this cost, specifically the example I've given you, this is called semi-fixed. Right? Mostly these terms are used interchangeably, but this is the fine difference between these. This function here is for the semi-variable cost. This is that you many questions on your software, but this kind of cost that's taking step, this is called semi-fixed. The fixed cost that stays same for the certain level of activity, then it takes jump, and then it goes on. Now, there's a very fine point further you need to know. This step function can be shown both by variable cost and by fixed cost. Fixed cost makes sense. We have just seen that your rent stays fixed for a certain space, but as the space is increased for storage, your fixed cost takes steps, right? And your variable cost can also take steps. Like, for example, your variable cost, we have just learned that it is supposed to be the same. Variable cost per unit is supposed to be the same. But what if, answer? What if your supplier gives you the quantity discounts? So in that case, your variable cost per unit could be this. As you keep on purchasing more units, your variable cost per unit tends to fall. Yes, they are not. Mostly they are used as interchangeable terms in most of the text, but this is the fine difference. You asked me, that's why I'm explaining, right? Otherwise, you will find semi-variable, semi-fixed as the interchangeable terms, but this is the difference between these two. Okay, now your step cost can be the step fixed cost, and your variable cost can also be step cost, just like material that you purchase could be, or maybe this could be opposite, totally opposite. Like your variable cost for a certain level stays at $10 per unit, but since the material is very short in supply, resultantly, any additional material you purchase costs more, right? Maybe 11 per unit. And after that, every additional unit you buy costs more. So the point you need to learn is that if these gaps are very small, right, tends to be very small, the steps are very small, we tend to take it as a variable cost. But if these steps tend to be wide, we take it the fixed cost. This is the description given here. Let me mark it for you. This one. If these steps are relatively narrow, these costs are usually treated as variable cost, right? But If the steps are wider, like these, like the jump is quite wide, like in rent, they are more akin to fixed cost. Now, this point is nicely explained in this question. This one. Look at this. What about cost B, answer? What do you think cost B is? You will argue, sir, it's changing. At 10,000, it was 10. At 12, it's 15. At 15, it's 15. It's a step fixed cost. It has taken a step at 10,000 and then it stays the same for certain range. Absolutely, brah. It's a fixed cost. So I don't need to go for any computation, despite the number is changing, but it has taken a wide step. Wide step. So wide step means it's a fixed cost. Now let us see what about the other cost. 25 by 10, it gives you 2.5. 29,000 by 12. 2.42. And 35,000 by 15, it is 2.33. See, it is falling on per unit basis. It's a mixed cost, which we call as a semi-variable cost. Semi-variable cost. What about the last cost? 15 by 10, it's going to be 1.5. 18 by 12, 1.5. And 22,500 divided by 15, it's again 1.5. So this is clearly a variable cost. So we have semi-variable, fixed, and variable. So that makes A to be the correct option. Right? A it is. All right. So we got the understanding. Next point here to learn, the last slide here, the concept marginal cost. Marginal cost. Now let me explain. Let's say I produce 1,000 units and my total cost at 1,000 unit was, let's say, $12,000. When I increased my output to 1,100 units, the cost went up to, let's say, just assume numbers, 13,000. Now, if I want you to calculate the marginal cost, the cost on per unit basis, the additional cost on per unit basis, if you see, I've increased my production from 1,000 to 1,100, additional units produced 100, and the cost went up from $12,000 to $13,000. So it is $1,000 additional cost. So if you divide 1,000 with 100, what you get is $10. So $10 basically is the cost of producing one additional unit after 1,000. This additional cost of producing one extra unit is called the marginal cost. So marginal cost is the cost incurred by one unit increase in the activity level of a particular cost driver. Right here, we have the number of units produced. So each unit you produce beyond 1,000 costs you $10 per unit. So marginal cost is also called the additional cost. This concept is highly testable on your section C, CM part 2, decision analysis. So right now, just remember the word marginal cost is the additional cost on per unit basis. Right, so marginal cost remains constant across the relevant range. And what is relevant range? The relevant range is established by your productive capacity, the contracts with your trade unions, or maybe with your supplier, and you cannot increase your production in the short run beyond that level. And if you increase, then the variable cost per unit may change. It can go up, it can go down. And your total fixed cost, of course, is most likely to go up. So beyond the relevant range, the cost behavior is unpredictable. It would change. That is what we know for sure. So in the short run, variable cost per unit stays same, and the total fixed cost stays same. They remain same in the short run. What about the long run? Everything is variable in the long run. All costs are variable because your variable cost per unit right now, it is still 10 per unit, but maybe after 1 year, it could be 12 per unit, or it is possible it might be 7 per unit, depending upon in which direction the cost has moved in the future. So right now, variable cost per unit is 10, 10, 10, the short run. But in the longer run, they may change upward and downward. Similarly, your total fixed cost, maybe it is $1 million for this short run, maybe for 1 year or 6 months. But after 1 year, this could go up, this could go down. So everything is variable in the long run. That's why it says all costs are variable in the long run, right? So that's the idea. Okay. Which of the following categories of cost is most likely not considered a component of fixed factory overhead? Rent is a part of fixed factory overhead. Property taxes is a fixed charge. It is a fixed factory overhead. Depreciation is also a fixed factory overhead. Power is not a fixed factory overhead because power is a variable component. As you produce more units, you consume more power. You produce less units or less machine hours, you consume less power, so less electricity bill. So this is one of the elements that you can consider is variable, that varies with the level of output, right? So that I think nicely sums up the idea of the cost behavior.